NASA confirmed Thursday that the Voyager 1 probe has made history by becoming the first human-made object.
The Voyager 1 is now flying in an unexplored region in space between the stars. NASA scientists are calling this a historic leap into space.
Voyager 1, a spacecraft launched in 1977 and now the farthest human-made object from Earth, has once again reshaped our understanding of space with a silent but profound observation. In the vacuum of interstellar space, billions of miles from the sun, where even the faintest signal is a triumph of engineering and patience, Voyager 1 captured data that suggests something extraordinary passed nearby. Unlike typical interstellar particles, dust, or meteoroids that follow predictable trajectories governed by gravity and momentum, this disturbance carried characteristics no known natural phenomenon has ever displayed. Its motion through the plasma-rich environment surrounding Voyager was rhythmic, smooth, and sustained, a sharp departure from the chaotic signatures typically associated with cosmic background noise or solar ejecta. The disturbance presented a decaying oscillation pattern in plasma wave data, and Voyager's magnetometer recorded a temporary deviation in the ambient magnetic field, reinforcing the notion that something physically moved near the spacecraft. The nature of the movement, its precision, symmetry, and apparent responsiveness immediately raised questions that defy conventional astrophysical interpretation. If the object was natural, it exhibited behaviors that do not align with any existing models of interstellar debris motion. Its consistent trajectory and subtle shifts suggested an ability to navigate or adapt to its environment, something far removed from the random movement of meteoroids or comet fragments. Even more confounding was its complete lack of electromagnetic emissions, optical reflectivity, or any other detectable signal except the ripple it left in the plasma. In effect, it was as if something passed by silently, interacting only with the medium itself and remaining completely invisible to traditional means of detection. This challenges the long-standing assumption that all significant objects in space can be perceived through some combination of light, heat, or radiation. Here, Voyager picked up only the echo of motion, a ghostly whisper through the interstellar sea, devoid of any visible trace. Scientists have since pored over the data with intensity. Instrument logs were double-checked for errors, software systems combed for faults, and external environmental conditions assessed for possible interference. None of these investigations yielded a satisfactory explanation for what Voyager encountered. The instruments performed as expected, and the surrounding space, calm and free from solar flares or cosmic ray bursts, offered no contributing cause. What makes this encounter so scientifically tantalizing is not only its uniqueness, but the level of precision inherent in the data. The rhythmic structure, the oscillation decay, and the symmetrical plasma fluctuations all suggest an event that was more than a random anomaly. It points toward interaction, an effect generated by a coherent body moving with deliberate speed and direction. This conclusion opens up a realm of implications, from advanced propulsion theories to entirely new models of how matter can traverse the interstellar medium. One of the more compelling possibilities involves a form of propulsion that manipulates the plasma and magnetic fields of space itself. Such a mechanism would not emit light or heat, making it nearly impossible to detect with standard observational equipment. This hypothetical propulsion, potentially akin to magnetohydrodynamic systems theorized in advanced physics circles, could allow an object to move by harnessing the sparse but persistent energy flows that permeate deep space. This would be a method of travel fundamentally different from anything humanity has developed, requiring no fuel in the traditional sense and leaving no thermal or optical signature. The object's ability to shift direction or correct its path could then be explained as a response to the medium it was moving through, utilizing localized magnetic field manipulation to change course in real time. Equally provocative is the idea that this object could be an engineered probe built by an intelligence beyond Earth and sent across the galaxy as part of an autonomous or observational mission. Voyager, after all, carries a golden record meant to communicate our existence to any who might find it. That something may have passed close to it, perhaps noticed it, or perhaps merely crossed paths with it, poses enormous questions about our place in the cosmos. If intentional, the flyby might represent the first recorded contact between human technology and a non-human artifact. If unintentional, it suggests that space is trafficked in ways we have not yet been able to observe, and that Voyager simply happened to be in the right place at the right time to catch a glimpse of that hidden activity. The design implications for such a device, stealthy, efficient, and capable of remaining undetected except through minute disturbances, are staggering. Our own spacefaring technology is still reliant on loud, heat-generating, and fuel-consuming systems. In contrast, this object moved with such silence and finesse that its presence was only known because of how it displaced surrounding plasma. This manner of interaction offers a new sensory paradigm for space exploration, one that relies not on visual detection, but on the perception of how the medium is disturbed. Much like how submarines can be detected by their wakes rather than visual contact, future probes might be equipped to sense the invisible currents of plasma and magnetic fields, listening for the subtle signals of passing bodies. The notion that the interstellar medium is a structured environment with properties that can be harnessed or manipulated is also gaining traction. Previously considered largely inert and empty, aside from sparse particles and background radiation, the region between stars is now being reconsidered as a potentially active and navigable domain. Theoretical models are being revised to account for possible energy pathways or plasma corridors, regions where the distribution of particles and magnetic fields might enable efficient travel. If such corridors exist and are being used by advanced technologies, then they would represent a kind of interstellar highway system invisible to traditional telescopes. Mapping these potential routes would require entirely new instruments capable of high-resolution magnetic field detection and plasma analysis, focusing not on visible matter but on the unseen framework that structures space itself. Voyager's detection has also catalyzed a deeper philosophical reflection. For decades, the prevailing model of space has been one of silence, distance, and vast emptiness. This event suggests otherwise. The cosmos may be active in ways we have simply not been equipped to perceive. What was once considered the void between stars may in fact be teeming with faint motions and hidden interactions that our current instruments overlook. The idea that objects, potentially artificial, are moving through these regions undetected raises profound implications for everything from astrobiology to the search for extraterrestrial intelligence. It implies that we may not be alone, and more provocatively that we may have already been passed by something intelligent without even knowing it. This raises a critical question about how we search for signs of life or intelligence beyond Earth. Traditionally, SETI efforts have focused on detecting radio signals or optical pulses, intentional broadcasts meant to be received, but this incident introduces the concept of passive contact, where presence is not communicated through deliberate transmission but inferred through unintentional interaction. If other civilizations employ stealth or simply do not wish to be seen, they may travel silently without leaving the kinds of footprints our instruments are designed to detect. Voyager's detection becomes a prototype for a new kind of SETI, one that listens for physical displacements rather than calls across the stars. From an engineering perspective, Voyager's success is also a vindication of long-term mission planning. Despite its age and limited capabilities, its enduring operational status allowed it to witness an event that might never have been noticed by a newer, more specialized instrument. This underscores the value of simplicity and longevity in exploratory missions. The spacecraft's rudimentary sensors, designed with fewer assumptions and less filtering, were uniquely suited to capture a raw, undistorted signal. This has led to a re-evaluation of future probe design, with some scientists suggesting a dual instrumentation approach that combines cutting-edge tools with low-tech sensors capable of picking up unexpected phenomena. Redundancy in this context becomes a pathway to discovery, not just a safeguard against failure. The psychological and cultural impact of the detection is equally profound. It has rekindled a sense of cosmic mystery at a time when space exploration often feels dominated by engineering achievements rather than philosophical wonder. The image of something brushing past Voyager, an emissary of humanity, a fragile metal outpost drifting through space, is deeply resonant. Whether the object was a rogue rock, an alien device, or an unknown phenomenon, it has forced humanity to reconsider its assumptions about what space is and how it behaves. The encounter didn't come with fanfare or spectacle, but with a whisper, an almost imperceptible touch that has set off ripples through the scientific community and beyond. In the realm of data science, the event has highlighted the importance of anomaly detection. Algorithms that process spacecraft data are typically optimized to recognize known patterns and filter out noise. However, in this case, what seemed like noise at first glance turned out to be a significant anomaly. This has driven a movement toward developing more adaptive and open-ended data processing techniques, capable of flagging events that don't match any predefined models. Machine learning systems trained to detect the unknown rather than confirm the expected may be crucial for future discoveries. Voyager's brief encounter thus serves as a benchmark for how to design intelligent systems that remain alert to the unanticipated. One of the more speculative but intriguing ideas emerging from this incident is that the object might not have been moving under its own power at all, but rather riding a natural current or wave through space. The concept of dynamic interstellar corridors, regions where the structure of plasma and magnetic fields create low-resistance pathways, suggests a kind of space oceanography. If true, then the object that passed Voyager could have been exploiting these invisible currents, much like ancient mariners used wind and tides. This possibility would revolutionize interstellar navigation theory and change the way we conceptualize space travel, even for human missions. Instead of brute force propulsion, future spacecraft might learn to sail space, adjusting their course based on plasma flows and field vectors mapped in exquisite detail. The timing of the event, occurring near the twilight of Voyager's operational life, adds a poetic layer to the mystery. After nearly 5 decades of silent observation and service, the spacecraft has perhaps delivered its final and most enigmatic transmission. That this anomaly occurred just as Voyager nears its power down phase seems like a cosmic nod to the enduring value of curiosity curiosity and patience. It's as if the universe waited until the final moments of the mission to offer one last puzzle, a riddle that may take generations to solve. The event doesn't provide closure. Instead, it opens a new chapter, one defined not by answers, but by the hunger to understand more deeply what lies beyond. The detection also speaks to the limitations of our current observational strategies. Most of our space monitoring systems rely on optical or electromagnetic signals, but if there are objects moving through space that do not emit or reflect these signals, then they are effectively invisible to us. This encounter serves as proof that presence can be known without being seen. It challenges the supremacy of light-based observation and introduces a new method of awareness based on displacement and medium interaction. In this sense, Voyager has expanded not only our knowledge, but also our senses, giving us a new way to feel the universe rather than merely observe it. This shift is being taken seriously in the development of future missions. Proposed spacecraft will carry instruments capable of measuring not only particle densities and magnetic fields, but also the dynamic interactions within them. These probes will be designed to listen rather than look, tuned to detect the disturbances and ripples that hint at movement through the medium itself. The idea is to create a distributed sensor network, small, long-lived spacecraft scattered throughout the solar system and beyond, each quietly collecting data on the invisible movements of interstellar space. Over time, this network could produce a map of space as a dynamic living environment rather than a static void. Voyager's legacy, therefore, is not just in the data it has returned, but in the paradigm shift it has provoked. It has revealed that there is more to space than stars and planets, more to exploration than propulsion and pictures. It has shown us that sometimes the most significant discoveries are not the ones we see, but the ones we feel. Tiny shifts in the plasma, slight tremors in the field, silent passages in the night. And it reminds us that in the end, the journey matters as much as the destination. For even as it drifts into the dark, Voyager continues to teach us how to look, how to listen, and how to wonder.